Good morning, everyone. Today we're doing Unit 5, Lesson 6, Word Problems Involving Sinusoidal Functions. So there's two types of functions we're going to talk about today, primarily the sinusoidal function, but I want to first talk about our periodic function. So a periodic function is a function for which the dependent variable takes on the same set of values repeatedly as the independent variable changes. So, for example, in this electrocardiograph, if you were to look at, you could see that there's a pattern from here to here to here. And then if you were to translate or move that over to the right, that would repeat itself over and over again. A periodic function, a sinusoidal function is just a periodic function that looks like a bunch of waves. So you can see with the electrocardiograph, there's a pattern, but it's not wave-like. With sinusoidal functions, they are wave-like. So if we were to identify in these three graphs down here, which one is periodic, which one is sinusoidal, and which one is neither. Well, this is our periodic one, because we have a pattern that's repeating. It's just not wave-like. These are our wave-like functions, which are sinusoidal, and we've seen them with our sine and cosine functions. And then this last graph would be neither, because it's not a repeating pattern. Even though it is wave-like, it doesn't repeat, though the waves are different heights. So we're going to look at some word problems as they relate to sinusoidal functions today. So we're going to first walk through kind of the setup of all of the properties when it's given to us in a word problem, and then look at more detailed examples. So the first example is Fred is on a magical bungee jump ride. At time t equals 0 seconds, he is 80 meters high, and 6 seconds later he reaches the maximum height of 20 meters. The ride is perfectly sinusoidal, so it's going to be wave-like, just like that sine and cosine function. Fill in the boxes. Time is the x-axis, so let's put time down here. Time is our x-axis, and height is our y-axis. So if we go back and read some of that details from the question, that says at time 0, so let's just put, we know that 0 is at our origin, he is 80 meters high. So if height is on our y-axis, then our 80 meters is going to be in this box here. And it says 6 seconds later, so remember time is on our x-axis, so that 6 seconds must go here. 6 seconds later, he reaches the minimum height at 20 meters. So now, at this point here, he's at 20 meters. So that's going to go there. And then it says the ride is perfectly sinusoidal. So we could figure out some more of this information. So if it took him 6 seconds to go from our maximum down to our minimum, then it's going to take another 6 seconds to go from our minimum back up to our maximum at 80. So that means this box is going to be 12. If we wanted to find the line between, well, that's just our axis. So to find our axis, we're going to do our maximum plus our minimum and divide it by 2. So our maximum is 80, our minimum is 20. So that is 100 divided by 2, which is 50. So that's what's going to go in this box here. Okay, so we're going to use this information to help us come up with the equation. For our equation, we need all those variables we've been trying to find in the previous few lessons. So our amplitude, or our vertical stretch, our K value, which is our horizontal compression, our D value, which is our phase shift, and our C value, which is our vertical shift. So our amplitude, if we wanted to figure out our amplitude, that's the distance from our axis to our maximum or our minimum. So the distance from here to here is 30. Our K value is simply found by identifying our period. We're going to take 360 and divide it by our period. Okay, well, our period in this case, to go from maximum back up to maximum, is 12 seconds. So our K value is going to be 360 divided by 12, which is 30. Okay, our D value, which is our phase shift, well, we have to determine which function are we shifting left or right. If we're starting at our maximum, okay, this graph starts at our maximum, so we know if we start at max, we should use our cosine function, right? Cosine starts at max and our sine function starts at the axis. So since it's starting at our max, we need no phase shift. Our phase shift is 0. And then our C value is simply our axis, which we've already determined is 50. Okay, so we've already identified we're going to use our cosine. Let's remember what our general form of our cosine function is. So it'd be A times the cos of K, and then in brackets, theta minus D plus C. So we're going to plug in all those variables we just found here to write our equation. So we're going to have 30 cos, and then our K value is 30. Theta, we don't have a phase shift, so I'm just going to close those brackets, plus 50. All right, so that was a nice example in terms of us being able to label the parts of the graph. And those are always the things we're going to try to label. We're going to try to label our maximum, our minimum, our axis, and then along our x-axis, where do some of those key points fall? At what time in this instance was our minimum? At what time was our maximum? And we could even identify when it hit our axis, right? If we look at our x-axis here, we could see that where does it hit? At what time are we hitting our axis at 50? Well, that's just halfway between 0 and 6, so 3. And then halfway between 6 and 12 is going to be 9. So we can identify those key points like we have been. Let's look at another example. So determine the equation of the function for the following data. So let's first plot this data. So I'm going to look and see what I have here to determine what kind of graph I need. I'm going to have our x and y axis. And it looks like on my x-axis, I'm going from negative 20 up to 160. So I'm just going to do a negative 20. And then I'll space out on this side all the way up to 160. And then on my y-axis, we need to take a look at how far we're going. It looks like we're going all the way from negative 1 up to 5. We'll just do 1, 2, 3, 4, 5. A little more squished up there. Okay, and I'm going to plot this data. So go ahead and pause the video, and just on a rough graph on your own, plot these points on your graph. Okay, so here's all those points plotted. Let's try to identify, again, some of those key characteristics so that we can come up with a function equation for this graph. So the equation of our axis, hopefully we can see this pretty easily by just seeing where is that horizontal line that cuts the graph in half. And we kept coming back to it as you're plotting your points. So our axis is at y equals 2. And let's remember, what part of our equation does that represent? That represents our C value. Our amplitude is going to be the distance from that axis up to our maximum. So we'll say amplitude equals, and that's going from 2 up to 5. So our amplitude is 3. And remember, our amplitude represents the A value in our equation. Now, if we're trying to identify our period, which will help us identify that K, we need to see how long is one period. So if I start here on my axis, when do I come back up to my axis again to start repeating that period? Looks like right there. So from negative 20 to 100, so that means my period is 120 degrees. So if I needed to identify my K value, K is going to equal 360 divided by that 120. So K is going to equal 3. So this next part, our phase shift, we always have to determine how much we're shifting this to the left or right, but then we need to determine, well, which function are we going to use? Are we going to use our sine or our cosine? So our sine is going to be where the graph starts at your axis, and your cosine is going to be where does the graph, if the graph starts at your maximum. So looking at our graph, we have to determine which of those requires the least amount of phase shift, the sine or the cosine. So I can see here that my closest max point is right there. My closest axis point is here, which is 20 degrees away from my y-axis. My maximum is only 10 degrees away from my y-axis, so I'm going to use that So we only had to do a 10-degree phase shift. So that's 10 degrees for my y-axis. So if I have to do a 10-degree phase shift to my maximum, we're going to use cosine. So which function are you going to use? We're going to say cosine, and that requires a 10-degree shift to the right. Okay, and remember that is the d value in our equation. So our cosine is the best fit. What is the equation? So let's remember our general form of our equation one more time. So y equals a times the cos of k theta minus d plus c. So we've identified all those variables. We should just be able to plug them in. My amplitude is 3. Our k value is also 3. We're shifting 10 degrees to the right, so we need to do a minus in here. And then our axis, or our vertical shift up, is going to be plus 2. Okay, let's look at a few more examples. Okay, this time we're going to get into some word problems and being able to translate the word problems into a sinusoidal equation. So the height in meters of a tide at a given location on a given day at t hours after midnight can be modeled using this sinusoidal function. So we have this function here. Let's kind of forget about what they're going to ask us and just identify some of the things we know. We have this transform function. We can identify all of our variables, our a, our k, our d, and our c. And we know what those variables represent right now. We can determine our maxima, or sorry, we can determine our period, how much it was shifted, up and down, left or right, and how much it was stretched vertically as well. So let's just start with, what's the length of this curve? So what's one period? So we can see that our k value is 30. So that means we're going to take 360 and divide it by 30. So a period for this tide is going to be 12. And in this case, we're talking about hours. So that makes sense because think about, if we're talking about time, and then this is going to repeat every 12 hours, so we should be thinking 2 cycles in one given day. And we can even identify how often are we going to hit those key points, so maximum, axis, and minimum. So our key points are every, and then we have to think about, we're going to take 12 and divide it by 4 to find those key points. So our key points will be every 3 hours. Okay? And then we can determine some more, but let's get into the questions before we dive too far in. So it says find the maximum and the minimum value for the depth. So to find our maximum and minimum, we have to kind of think about our curve, right? If we thought about our regular sine curve, how can we look at this to determine where our maximum and our minimum fall? We know our maximum is at 1 and our minimum is at -1. Okay, and then our key points are 90, 180, 270, and 360. And it starts at our axis, goes up to our max, down to our axis, down to our minimum, and back to our axis. So if we were going to look at this and identify, how do I identify my maximum? My maximum is always just going from my axis up, whatever the amplitude is, right? Taking my axis and I'm adding the amplitude to it. And to get to my minimum, I'm taking my axis and I'm subtracting my amplitude from it. So we need to identify our axis and our amplitude to help us here. So in this equation, our axis, which remember is just the c value in our equation, is 7. And our amplitude, which is just the a value in our equation, is 5. So in order to identify our maximum, we're going to take our axis and add the amplitude to it. So our maximum is going to be 12, and in this case, meters. Our minimum is going to be our axis minus our amplitude, or 2 meters. Okay? What time is high tide and what time is low tide? Well, we just figured out the value at high tide, right? Our high tide is 12 meters and our low tide is 2 meters. So if we're trying to identify what time that happens at, we can just substitute that in for our height to find time, right? So we're going to sub h of t equals 12 for our high tide. Okay, so into my equation, I'm going to substitute a 12 in for my height, and then I'm going to just leave the rest of the equation. And now I'm going to try to isolate for t to figure out what time that happens. So I'm going to subtract 7 to the other side. And then we're going to divide by 5 to get rid of this 5. So divide by 5. So now we have 1 equals the sine of 30. You have to remember that this is all, we're taking the sine of all the stuff inside of our brackets. So from here, I need to move that sine over. So I'm going to do the sine inverse of 1 in order to clear it from my right side. So we'll have 30 times t minus 5 on this side. So the sine inverse of 1, well, if we look over on our regular sine function, we can see that the sine at 1 is 90 degrees, or the sine inverse. So 90 equals 30 t minus 5. I'm going to divide both sides by 30 now. So we'll have 3 equals t minus 5. And then finally, we're going to add 5 to both sides. So we'll see that t equals 8. So therefore, high tide is at, remember our t is represented by the number of hours. T is the hours after midnight. So if we just found t to be 8, then we can say high tide is at 8 a.m. because it's 8 hours after midnight. Let's look at low tide. So low tide is when our height is 2. So we're going to sub 2 in for our height. And then just repeat that algebra. So go ahead and pause the video and see if you can work through the algebra to isolate t. Okay, so when we isolate for t here, we should get that t is equal to 14. So remember that t represents the number of hours after midnight. So 14 hours after midnight would be 2 p.m. Something I want to remember and draw your attention to, though, is that remember we said our period was every 12 hours. Our period is every 12 hours. Okay, so if our period is every 12 hours, that means our tide, or our cycle of our tide, is going to repeat every 12 hours, which means 2 times in a day. So we have to think about, if high tide is at 8 a.m., when else will high tide be? Well, it's going to be 12 hours later, so it's going to be at 8 p.m. And the same is true for our low tide. It's at 2 p.m., but it's also going to be at 2 a.m. because it's going to be twice in any given day. All right, so that's the idea behind high tide and low tide. The next question is just kind of subbing in somewhere else. So it says, what is the depth of the water at 9 a.m.? So now we're trying to find the height when t is 9. So sub t equals 9 in. Go ahead and sub in 9 for t and see what you get. So when you sub in 9 for your height, writing it in function notation, then you should get 11.33 meters, and then always put a therefore statement with your word problem. So therefore the depth at 9 a.m. is 11.33 meters. Okay, one more word problem for today, and then we're all set. So a small windmill has its center 6 meters above the ground, and the blades are 2 meters in length. In a steady wind, one blade makes a rotation in 12 seconds. Use the point P as a reference point on a blade started at its highest point above the ground. So we're going to use point P because it's going to be at its highest point above the ground, which would be when it's straight up and down. Let's try to label some more information on this windmill. So it says its center is 6 meters above the ground. So from here to the ground is 6 meters. The blades are 2 meters in length. So 2 meters for all of them. And from here to here, 2 meters. Okay. One blade makes a rotation in 12 seconds. So if we were saying that this was making a rotation here to here and then to here, okay, all the way back around would take 12 seconds. Well, if it takes 12 seconds, we can identify how long it takes to make kind of a quarter turn, right? This would be 3 seconds, and then 6, 9 seconds, and 12 seconds. Hopefully we recognize with that these quarter rotations, because there are 4 of them, they also represent our key points. So our key points are going to be every 3 seconds. All right. And its highest point. So we start at the highest point when we're representing this function at t equals 0. So we should be thinking highest point. We know which function we should be using. So it says, what is the best model for this situation if the blade starts at its highest point? So highest point, we're going to use cosine. Okay, we are going to sketch this graph in order to answer some additional questions. So we're going to identify all of those values and go from there. So let's first sketch what's happening in this situation, okay? We've already talked about some things. We know that we have some key points, and they're going to happen every 3 seconds. So let's label 3, 6, 9, and 12. We also know that the middle of this windmill is 6 meters. So we know the middle is going to be 6 meters. So if we think about what's the maximum height of point P, well, the maximum point is going to be 2 meters above that because we have to take into consideration the height of the blade. So our maximum is going to be 8 meters, because I don't need meters there. So if I just put over here, my max is going to equal 6 plus 2. And then if I was trying to find my minimum, we would just do 6 minus 2, which is 4, right? Because that blade is going to be 2 meters, so the point is going to drop down 2 meters from that center, which would be at 4. Okay, it says that the blade is going to start at its highest point, which is at 8, and then we know it's going to hit those key points every 3 seconds. So for cosine, we're going to our axis, and then we're going to go to our minimum, and then back up to our axis, and then back up to our maximum. It'll look something like that. So from there, in order to write our equation, we're going to figure out what the equation of this would be. We need to identify those variables that we keep working with, A, K, D, and C. So our A is just our amplitude. So if we identified our axis as being the middle of our windmill, so that's at y equals 6, then our amplitude is just the distance up to our maximum or down to our minimum, which is 2, which also represents our blade length. Our K value, which is determined from our period, we're going to find our K value by doing 360 divided by however long it takes for one rotation, which is 12. So that is 30. So our K value is 30. Our phase shift, we don't need a phase shift for a cosine function because it starts right at our max. And then our vertical shift is also our axis, which is at 6. So our cosine function is going to be 2 times the cos, and then our K value is 30 theta. We don't have a phase shift for this one, plus 6. Okay. It says, what is the best model if the blade started at its lowest point? Well, if it started at its lowest point, we're still not on the axis, right? We're still on that extreme of max or min. So we're going to use the cosine function but just make it negative because that will reflect it. Remember, if we make it negative, it reflects it, so all the points flip over the x-axis. So just negative. And then finally it says, if the equation in part A is used as the model, what is the height at 4 seconds? So remember that we are using height, and actually this would have been better. I'll change this. Let's use our function here to say that it's going to be the height relative to our time, right? Because we know that our x-axis is being represented by time, and our y-axis is being represented by height. So we'll just use function notation for our x and our y's there. So if the equation is used, what is the height at 4 seconds? So we're going to sub t equals 4 in, and I'll again use my function notation. So h of 4 equals 2 times the cos of 30 times 4 plus 6. So let's simplify what's inside our brackets first. So 120, we're taking the cos of. And then when you do this on your calculator, just make sure you do the cos of 120 times 2 plus 6. Don't forget about your order of operations. So when you do that, you should get 5. So therefore, the height of the blade at 4 seconds is 5 meters. And you could even see that on our rough sketch that we did up here. If we looked at where 4 was, 4 would probably be somewhere there. And if we followed that across, looks like it's going to land right around 5 meters. Okay? So on the graph and algebraically, we can determine that. That's it for your notes for today.